The real and imaginary parts of a complex number are related by the next differential equation. By solving the differential equation, shows that the relationship between the modulus and the argument of the complex number is this expression. So let's solve this differential equation. We can see that if we solve for dy over dx, we get that it becomes negative x minus y, or y minus x over x plus y, and if we divide each term by x, we get that it becomes y over x minus 1 plus y over x, and we can see that dy over dx is a function of y over x, and for such type of differential equations we apply the next substitution. Y is vx, where v is some function of x. It's not necessary to solve for dy over dx. You can just notice from the initial equation that if you divide each term by x, you get 1 plus y over x dy over dx plus 1 minus y over x, and hence deduce that dy over dx is a function of y over x, and then apply the next substitution. So we differentiate this substitution, so it becomes dy over dx is, since it's a product, we apply product rule, and it becomes x derivative, it's 1 multiplied by just v plus x dv over dx, and hence dy dx becomes v plus x multiplied by dv over dx is equal to y over x, it's v, so it's v minus 1 over 1 plus v, or let's write v plus 1. And we can see that we can move v to the right, simplify it, and try to solve by separating variables. So x dv over dx is v minus 1 over v plus 1 minus v. Let's make a common denominator. So it becomes v minus 1 minus v squared minus v, and it is equal to negative v squared plus 1 over v plus 1, and it becomes v plus 1 over v squared plus 1 dv is negative dx over x. So we can see that we can solve it by separating variables, or actually try to find integrals. So we integrate both sides, and what can we see here? Let's split the left hand side into two integrals, and it becomes integral v dv over v squared plus 1 plus 1 dv, or just dv over v squared plus 1 is negative integral dx over x. Its directly arctangent formula is given in a data booklet, and to find this integral we can see that we can apply the next substitution. Let u be v squared plus 1, and then as usual consider du dv, which is 2v, and hence this integral becomes v, and dv is du over 2v, and v squared plus 1, it's u, v cancels, and we can see that it becomes a half integral du over u, it's ln the absolute value of u plus some constant, and it becomes a half ln of the absolute value of u, and it becomes absolute value of v squared plus 1. It's positive, so we cannot write these bars, so it becomes a half ln of v squared plus 1 and plus some constant. So it becomes a half ln of v squared plus 1 plus arctangent of v is negative ln of the absolute value of x and plus some constant. And v it's y over x, so we can write that it becomes a half ln of y over x squared plus 1 plus arctangent y over x is negative ln of the absolute value of x plus constant. And it is given that there is a point 1 root 3, so we can substitute it to find c, 1 root 3. So it becomes a half ln of y, it's root 3 over 1, so root 3 squared 3 plus 1 ln of 4 plus arctangent of root 3 is negative ln of 1 plus constant. It's 0. Arctangent of root 3, so it's tangent sine over cosine. Sine to be root 3, it's what? It's 60 degrees or pi over 3, so it's pi over 3. Hence, we can see that c is a half ln 4 plus pi over 3. 4 it's 2 squared and it becomes a half times 2 ln of 2 plus pi over 3, and it's just ln 2 plus pi over 3. Ln a to the power of b is b ln of a. Formula is given in a data booklet. Hence, it becomes a half ln over y over x, or let's rewrite. Let's do a common denominator, so it becomes y squared plus x squared over x squared plus arctangent of y over x is negative ln of the absolute value of x and plus ln 2 plus pi over 3. And we need the modulus and the argument arise here. But what is modulus? Modulus it's square root of x squared plus y squared, and argument of a complex number, it's arctangent of y over x. So we can see that it's theta, its argument, and it's r squared, but we can see that we should get rid of x here and here, and we can notice that if we move this ln to the left, it becomes a half ln over y squared plus x squared, and we know that ln of division is the difference of two ln's, so it becomes minus a half ln of x squared or actually it's not necessary to move it, or let's move to the left, so it becomes plus ln of the absolute value of x, and we can move 2 in front here, it becomes just 2 and ln of the absolute value of x, or here just 1 in front of ln, it's 2 over 2, and move this 2 here and it becomes ln of x squared. So anyway, these two terms cancel. So plus arc tan y over x is ln 2 plus pi over 3. And it becomes a half ln of y squared plus x squared, it's r squared plus theta is ln of 2 plus pi over 3. And 2 moves to a half and it becomes ln of r, and move theta to the right and it becomes negative theta plus ln 2 plus pi over 3. And since we need r, let's undo ln, so just by definition it becomes r is e to the power of minus theta plus ln 2 plus pi over 3, and it is equal to e to the power of ln of 2 multiplied by e to the power of pi over 3 minus theta. Just apply rules for powers, and e to the power of ln 2, it's 2, and multiplied by e to the power of pi over 3 minus theta. And we can see that we get that the modulus is equal to 2 e to the power of pi over 3 minus theta as required. And that's all for this question.